Hi there. So I'm kind of curious, how many of you in this room have already played with IPv6 routing? Most of you. I was going to say, what are you doing here? So anyway, so Ron Bonica and myself will be presenting this. I am not Philip Smith. He couldn't make it. There was a conflict with Minog. So since I configured IPv6 routing like in 2005, 2006, I figured I could fill in at least where needed. So Ron's with Juniper. I'm with myself. Used to be at Cisco years and years ago. And anyway, I guess we'll get started.
Hello, I'm Ron Bonica. We're going to be painfully honest with you at the beginning of this talk. Merike and I have never given this talk together before, so we have no idea how well it goes. But what we're going to do is make believe for a minute that she and I work for a fictitious ISP. We'll set up our website at fictitious.net or whatever, and we're going to activate IPv6 for the first time. We have some routers from brand J and brand C, so we'll show you some examples. We have some other problems that we're going to need to deal with on day one. So let's leap into this exercise. And I guess we have two problems right off. The first problem is configuring our, well, we don't know which problem is first. One problem is configuring our network. Come closer to the microphone? Okay. One problem is configuring our too loud? Okay. One problem is configuring our network, and the other problem is coming up with an addressing plan. And which one do you think we should tackle first?
Oh, I definitely think the addressing plan, because how do I even go about getting an IPv6 address?
That's a good idea. And it's very lucky she said that, because those are the first slides in the presentation.
Go figure.
Well, that slide doesn't matter that much. Topics and goals. Well, what do you know? We touched on that already. Addressing. Well, you're going to need some IPv6 address space, and you know that shtick pretty well already from IPv4. The same RIRs that dole out v4 address space dole out v6 address space. The one difference between the two, well, it's the same people, but you'll notice very different responses when you ask for address space. Ask for v4, a big chunk of v4 address space, and you'll meet the pit bull here. Ask for v6 address space, and they're very happy to accommodate you. By the way, that's Rocco.
Yeah, so anyway, all the regional registries you can get an IPv6 address from. There's some slight deviations in terms of policies because there's still that controversy that's been ongoing for the last, I don't know, at least 8 years that I've been hearing about it, about whether or not, a /32 allocation from an RIR is big enough, too much, too little, should it be /56, what should people do? So there's still controversy and ongoing policy issues. And if you're actually interested in this, I would encourage you very strongly to go to whatever region you're in. I would imagine most of you are here in the Aran region, but some of you that may have traveled from other areas, if APNIC or RIPE or LACNIC or AFRINIC is where you're from, then I would encourage you to actually participate in some of these policy discussions. Besides the RIRs, you can also get address space from your upstream ISP if you're a smaller ISP, or you could also use 624.
In fact, that's fairly important. Merike and I are assuming that we're both an ISP, so we'd go directly to the RIR. How many of you folks are representing enterprises and not ISPs? About half. Okay. All right,
this just shows a picture of the different internet registry regions. So in terms of getting IPv6 address space, if you're not a member, if you're an ISP, you should become a member of your regional internet registry and get your own allocation. Basically, all of the IPv6 allocation policies that are current and also some proposals are all documented in each of the RIR websites. If you're an existing IPv6 resource holder, some RIRs give you IPv6 just on request, i.e. APNIC. So just a little bit of history on that, right? I mean, there's been a lot of encouragement from the IRRs to get people to actually start playing with and deploying IPv6. And while there's still some notion that it's only, 128 bits in terms of addresses, that's it, nothing more, I think those of you that have actually actively been using it and deploying it know that, there's a lot of other considerations, actually. There is plenty of IPv6 address space, and most of the IRRs actually do require high-quality documentation in terms of how you actually use that space. Okay. You can also get IPv6 addresses from your upstream ISP. So typically, you get a /48 from your upstream ISP, and you can get more than a 1/48 if you have more than 65,000 subnets. So just as an aside, I actually worked for Connections by Boeing in 2005, 2006, and Boeing itself had gotten their own /32. And we were very actively playing with it. I actually had EIGRP going live with NTT, and this was December of 2005. And from what I understand, we were the first /48 as an enterprise that got routed by NTT. I was told by some people later that they absolutely hated me because it started this engineering internal discussion, to put it mildly. Right, but I think the key is to just really start using it. Most of you have said in here that you have. So get an address from your upstream ISP, or also use 624 if you actually need to do that. So the 624 is really the last resort, and really for simple testing purposes. It's much better if you actually get your own v6 allocation. And how 624 addressing works, you basically take a single IPv4/32, and then you insert that after the 2002:, enter that as your the IPv4 address, and that becomes your /48 subnet. It also requires a 624 gateway, and I'll let Ron actually talk a little bit more about this as well.
Let's ask some funny questions right now, kind of, hedging the bets against our retirements. If I had been around 30 years ago, I would have snarfed up a few /8s, and I would have kept them in my pocket until there was value later. Given that IPv6 address space is so large, I probably don't want to play that game this time, do I?
I wouldn't.
Well, I know you wouldn't. You're a nice person. Now, the question is, would I? Probably there's no economic benefit in that.
I don't think so.
Because in the world of /48s, there are an awful lot of /48s in the IPv6 address space. Okay. Talk to us more.
Okay. So in terms of address blocks for router loopback interfaces, generally a lot of people, what they do is they number all loopbacks out of one single /64. And so you have a /128 per loopback. Also for address block infrastructures, a /48 allows for 65,000 subnets. Typically there's a /48 used per pop or region. A /48 for whole backbone, and summarizing between these sites really makes sense. Now, every 6 months I either watch the v6 ops mailing list that's run out of clunet.de or nanog list, and the thread, there's a similar thread all the time in terms of what kind of allocations do you actually use for your subnets. So mostly what we're describing here is what makes reasonable sense. And again, I didn't create these slides. Philip actually does a lot of these tutorials, especially around the APNIC region, and also he's done it here at Nanog and at RIPE. And these are basically the allocations that both him and Ron believe are the most reasonable. There are some variations, and I still remember doing a survey in 2006, 2007, where I asked people, so what do you use? And I asked 5 different people, and I got 5 different answers. So, but again, like what I would encourage you to do is also take a look at some of the threads from the NANOG list that, and I know that this year there's been at least 2 of them, you know, in the last 12 months, about what do you actually use, how do you allocate your address space adequately.
Now, aside from the fact that if you use a /48, you have room for 65K subnets left, there's absolutely nothing sacred about any of the numbers on this page. If you and I decide we like 49 better than 48, the router will accommodate it just fine.
Right, at least most of the bigger routers will. So one of the things also to actually look at is some of you are, you know, have different networks. You're not just, you know, using Cisco or Juniper stuff. So if you're looking at CPE devices, which are also now becoming more and more IPv6 aware, I would also look to see what they do.
Two more pieces of addressing guideline. First, what about the LAN? There's a recommendation here for a /64 per, well, this is even more than a recommendation, it's from an RFC for a /64 per subnet per LAN. The next question is much more controversial, and I think it's on Tuesday we're going to have a panel to talk about this. Let's say you've got a point-to-point link between 2 routers. How should you number that? Well, strangely enough, the current, well, I shouldn't say strangely, but the current recommendation is to use a /64. That seems a bit wasteful for a subnet that will never have more than 2 endpoints on it. What's more, it leaves you to several security vulnerabilities that we'll talk about much more on Tuesday. So if you take a look at you know, advice coming out of the IETF, today they're saying a /64. Lots of people are using 126s, some are using 127s, some are using a pair of 128s on a real point-to-point link. Some people use 112 because it accommodates reverse DNS lookups nicely. Other people are using all sorts of other things. So we'll discuss really what the right thing to do is on Tuesday on this point. And I'd like a bunch of people to present their input. We'll put it together and send it to the IETF as a recommendation from operators.
Okay, so if you're an ISP, right, basically a customer would get a /48. Unless they have more than 65,000 subnets in which they can get a second /48. But some ISPs are also distributing /56s and /60s as initial customer assignment because they feel that, let's say it's a small customer, you know, /48 is actually quite a bit of address space. So your mileage may vary, and you know there's still quite a bit of controversy actually in what to give out. Traditionally, it's been a /48, but I personally have actually seen a lot of /56s. For the customer, the addressing plans, I mean, they should not be reserved or assigned on a per pop basis. ISP IBGP carries customer networks. There's aggregation within the internal BGP is not required and usually not desirable. And aggregation in eBGP is very necessary. Right? One of the biggest issues actually facing the internet as a whole as more and more B6 starts getting utilized is how do the routers actually handle the routing tables. And you know, we'll see how that all progresses. And I can't remember now what the size of the routing table is in V6. I think it's about 16,000. Does anybody actually know? 2,700? Okay. So right now we're at 2,700, you know, BGP routing table entries. And summarization is definitely really important in aggregation.
Okay. And I guess this is a little picture of our addressing assignment. We aggregate, we assign 1 /64 for our loopbacks. Oh, I'm sorry. This is a picture of our addressing strategy. We assigned 1/64 for our loopbacks the same way we said we would. We advertise, where's my cursor? We assign this chunk for infrastructure and this bit for customer assignments.
Yeah, so since most of you actually have deployed some IPv6, I would imagine that most of you have an addressing plan. What I'm kind of curious about is that if you're an ISP, how many of you do not give a /48 out to your customers? Not. What do you give out? You do? Okay. And the rest of you, I mean, how many of you do give out a /48? Okay. So.
That comes to a total of 3 people, and I saw a lot more hands at the beginning of this. I guess some of you are enterprises.
Yeah.
How many of you, let's ask the question again. How many of you either give or receive a 48? That or that, yes. How many of you give or receive something smaller?
Just the one for this. Right, so it really depends on who the customer is. Yeah. Yeah, I mean, as you'll note, I mean, there's the rules that people established years ago, right, are really in the process of saying, you know, these policies, I mean, while we think that IPv6 has a lot of address space, there's still a little bit of a notion by some people that, you know, we need to be careful about how we allocate things so we actually don't run out. You know, I don't know how many of you have done this. I was actually stupid enough to create spreadsheets for all of the /64s. It was a lot of numbers, you know, and my coworkers were like, why are you doing this? And I, you know, after like a day I said, you know, I don't know. But it kind of proved to myself that really there are a lot of numbers there. But you do want to have some kind of sensibility in terms of how you actually allocate the space, right? But I don't think we have to be as concerned as maybe some people are.
While we're being numerical, how many of you have ever gone back to the RIR for a second /32? Didn't think so. I don't know. Oh, one of you have. And did you actually?
I think you guys are asking the wrong questions. It's not so much the allocation of the block, it's empowering the customers to actually do something with IPv6. So right now, the only choices are for them to dual stack their perimeter so that, you know, their DNS servers, their web servers, and their email servers are properly configured to support IPv6. But it all works from a networking point of view. There aren't active security tools out there that will help support this. If you go under the premise I go under, which is a firewall, it's not a security. So,
Well, this particular session is more about routing, right, and actually doing IPv6 routing. And you are absolutely correct. I mean, you know, when I configured it in 2005, I was very much happily surprised that it really just worked. The stuff that didn't work was the management stuff, right? Or, you know, I am actually a security person, and boy, that's abysmal. But so we're really discussing the addressing plans in terms of more from a routing perspective and from actually the core network. Jake, did you have a comment?
Hi, I'm just curious, how many of you people are actually filtering IPv6 routes at your edges? And if so, what sites are you filtering on?
Good question. What are you filtering on?
So you don't have a minimum size or?
Well, I guess it's that question, you know, so you know, size or any announcements or for specific classes of addresses. Like, I don't necessarily think it's long period, but I think what he's talking about is by application size.
Marley Zinger, Frontier Communications, and I'm on the Air and AC I don't want to hijack your presentation because it's good, but this topic of addressing and routing is actually a big issue right now with errand policy, and there have been proposals put forward that will dig into this even deeper and can really screw with routing if they pass. And if we don't get people like you at the meeting to vote on it, because it actually is addressing what filters will be. Your response kind of really keyed me up because you said you're doing what the RIRs are saying. Well, if you keep doing that and some of these policies pass, we're going to have serious issues. So it's a great topic. I'm sorry, I don't want to hijack anything, but the subnet boundaries and filtering is important. And I think people need to know that, yes, our routing tables are getting large. Filtering kind of does need to be done, but we need to be conscious about not blocking off things like multi-homing, which is very much in danger, and traffic engineering is in danger. Thanks.
Yeah, no, I'm actually glad you made the comment because it also really emphasizes what I had mentioned earlier, that, you know, if you can and are really interested, then please participate in the RRR's, you know, addressing policy issues and controversies. So.
Speaking of addressing policies, actually Marla can confirm this or not. If you ever run out of your first /32, when you reserved the first one, the RIR reserved a second one for you, so you'll get two. Do we not do that anymore, Marla?
That's one of the proposals that would change that, which I see as a problem because it proposes that now you can only get 132 and you can qualify to get one of the other subnets, but therefore the whole reservation fact goes away. Well, then you're doubling your routing. So, yeah, no, right now it is, but it may not be in a couple months if people don't speak out against it.
Actually, I think this is probably, you know, your comment is probably a little more interesting than our talk. So if I could ask you, if you don't mind being put on the spot, if you could run through quick bullet points of the dangerous proposals.
I don't have the names of them memorized, sorry. I have to use cheat sheets, I'll confess. I use them like crazy. But there's two specifically that it involves addressing and what is supposed to be proper addressing just to try and maintain control and not waste. However, it's getting into routing because there's proposals. One is saying, hey, let's make 48s only come out of this chunk here and 32s only come out of this chunk here and so on. And if you do that, you've now, in a way, classified addressing and made it possible for people to filter out certain subnets. And some people might look at that as a good thing and some might look at it as bad. You might look at it as bad because you have a smaller subnet. Let's say you've got a larger ISP and they have a large supernet themselves and they only want to mess with their own routes. They don't want all these, as many customers coming to them with, I've got my own address space, please route it here, please route it there. Instead we want to go, hey, here's ours, use it for multi-homing, get your other ISP provider to route it as well, and you're good to go. But if you start doing these boundaries where you can filter, then you start running into roadblocks. So I might not be able to actually give my customer a /48 and have it multi-home.
Marla? So
because it came out of the 32.
I want to see if you really understand something that you said at the beginning of the comments. That's actually kind of a return to classful addressing?
In a kind of a different way. That's why I don't want to use that word because it's classifying groups, but it's not classifying it in the same way. So please let me make that clear. It's not the same thing.
There aren't any bits that indicate the class, but if you take a look at an address, by looking at that address and looking at some other table, you know for certain it's a /48.
Right. Yeah. Yeah. So let's see. So there's that, and that could cause. There is no multi-homing solution for V6. The solution is networks just do it and let it work. However, if there's policy like that, now we've got a whole bunch of roadblocks in the way of letting it work. And some people on the other side might go, well, hey, great, because then the routing tables won't grow too much. Well, that's really not the case because you keep hearing people say it's 1-for-1. People don't want to have to change their addresses when they go to a different provider, but, and that's a whole nother topic. I hear you, but I'm doing it all the time. That's what I do, and it works. It's okay. But you're going to have just as many routes. So it's not putting those separations there and saying this is out of this block is just going to put more roadblocks up for networks, and operators are going to struggle trying to get their customers up to let them do multi-homing. I'm sorry, I think I babbled.
Yeah.
You actually added lots of value. So thank you.
Okay. Yeah. All right, Jake, and then we're going to continue.
So this kind of brings to mind a question then. Are any RIRs working on a BCP of some sort to sort of specify a good policy for using RIR allocations for filtering? Is that a goal here?
It's not a goal. There is no BCP yet. There were people at the last NANOG that stood up and said, hey, that'd be great to do. And then there was a group that kind of went to dinner, and I haven't heard anything come out of it. So no one's taken ownership for it. It's not on the charter for Aaron. It's not on the charter for NANOG.
Should it be on the charter for V6 ops?
Maybe so, Ron. Maybe we should do that.
I'd be perfectly willing to put it on the charter if somebody would say.
I would help you with that, actually.
You'd be glad to be an
Yeah,
editor?
yeah. Okay.
Anybody care to help? You're hired.
Okay. You're hired. So to answer the question, no, not right now.
I'd be happy to help too. But I have one other question with regard to all of this, is that right now, a lot of the equipment routing manufacturers are really basing a lot of these decisions on how much memory to allocate within the routers or routing tables based on a lot of these conversations and feedback. So, whereas typically, we have some large amount of memory allocated to IPv4 within our routers, there is a significantly smaller amount of memory allocated to IPv6 with consideration to the fact that, people are going to be, supernetting a lot. So that should also be some consideration, feedback to these manufacturers about
Well, I agree that. The question is, should the tail wag the dog or the dog wag the tail? Maybe operators should be, writing their filtering policies and letting the vendors do what the operators need rather than.
I agree with you. Maybe I was inarticulate, but yes.
By the way,
Exactly what you just said.
I didn't say that. I work for a vendor. But anyway. By the way, would you two get in touch with each other so you'll know to work together? And okay, we talked about registries, document. Let's see, at this point, how much time do we have in our talk?
Or no?
Should we move on to configuration?
Yeah.
Let's do that. What do you know? How convenient. Okay.
Can I pose a question related to documentation?
Please.
Are there some RIRs that actually are easing up on the documentation requirements for prefixes allocated to customers? Because I've heard something like this, but I've yet to verify this information.
Well, let's see. That's probably a question for Marla.
So are there some RIRs that actually have eased up the documentation requirements of IPv6 customer allocations compared to V4 allocations?
Have they eased up on the requirements?
Yes, so that you don't have to document every single end customer, so to say.
The only region I'm aware of that has very liberal, non-existent justification is AppNIC. All the other ones have been still requiring it. It is a little more loose because we don't know what to expect. You have one camp saying you can IP address every grain of sand on the earth, But when you look at history, it repeats itself. And there's a finite number, again, IPv6. So we don't want to just open the floodgates and say, hey, have at it, because we're just going to be in another world of hurt. So there is still justification required, and that the Aaron region, and I can only speak firmly to the Aaron region, and we are sticking to that. We will be continuing to do justification. What exactly the extent of that will be as time goes on, I can't answer, because I don't have a crystal ball to really say that one.
Yeah, you know, and I'll have to validate this, but I was reading on a mailing list just, I think, a couple of weeks ago that the RIPE, actually, region is being maybe a little bit more loose with IPv6 and IPv4, but I need to validate that for sure. But
Yeah,
I'm pretty
if
sure
you
that I
look
heard
at it,
that.
it is a little more loose, but the only one that's really not there is AFNIC.
My comment is here just because of the good registration is an essential part if you look into things from the security viewpoint. If you really want to contact the end customers directly who actually have an operational role, it is an essential thing that it is at the same level as with V4, that all the customer assignments are properly registered. It helps this works of certs and abuse handlers a lot.
Right, I agree. I mean, you want accountability, right? So.
Okay. Well, now we've got all our addressing policy at least as clear as it's going to get, with questions about how we really must do things or what policy should be, and people kicking off new BCPs. So now it's time to start configuring a router. And I guess the very first thing that we should do is, on our iOS routers, tell the router that it's going to do V6. And the way to do that...
Right, so to enable IPv6 on a Cisco iOS router, you basically have a global command, which is IPv6 unicast-routing. You also want to enable Ceph, because it's not on by default, and you just do that by the command IPv6 Ceph. You would also want to disable IPv6 source routing, right? Just as with IPv4, you just really don't need it. And you would say no IPv6 source routing. If some of you have followed this for a while, right, with IPv6, you have this issue with the routing header 0, and it's actually been the cause of some security issues, if you will. And so with no IPv6 source routing, it just turns off using the routing header 0. For iOS XR routers, IPv6 is on by default, so that's different than just iOS. Configuring interfaces on either iOS or iOS XR, you do an interface. Under the interface command, you just say IPv6 address, and list the address and prefix. You can also do an automated EUI64-based IPv6 address, but typically this is really, nobody uses this on routers, right? Because generally you want to know what the actual IPv6 address is. But if for some reason you did want to use that, you would just under the interface say IPv6 address, the prefix, and then EUI64, and that would then take the MAC address and create an EUI64-based IPv6 globally unique address. So okay. One of the things that I'm going to point out here now is that I have seen people that would actually play with their IPv6. They just kind of turn it on. Sometimes you don't have a test router, so you actually would just see what happens if you enabled it on your production network. And what was really fascinating to me was that you would have, you know, your SSH access for IPv4 and your filters and all that, and you totally forgot to do that for IPv6. So because you enabled IPv6 now on your routers and had access with interfaces, that means that if I just kind of knew what your IPv6 allocation was and happened to know what your interface address might have been, I might try to SSH into it, you know. And it's, you know, you want to at least put in the same kind of control plane filters for your IPv6 to make sure that no miscreant traffic kind of gets at it. So it was just kind of interesting because I've seen that actually in a lot of environments, and in some environments that really should have known better. So just a caution.
Okay, and now for configuring IPv6 on your Junos routers. System-wide, it's on by default. What you need to do is something slightly different as you are defining an interface. As always, you need to define that you have interfaces on the box. You need to define a physical interface, FE300 in this case. You need to define a logical interface on it, unit 0. All this you would have had to do whether it were v4 or v6. Had this been a v4 interface, you would have said family, INET, address, and a v4 address. In this case, it's family INET 6, address, and a v6 address. You could have turned them both on if you wanted it to be a dual stack interface. Have one stanza that says family INET 6, another that says family INET 4. In fact, there's an example of it. And you saw EUI64 syntax in iOS, XR. Same syntax here in Junos. That's what the address blah, 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 EUI64 is about. And let's see. Okay, we're back in Cisco land.
That's kind of both.
Oh, no,
Basically,
we're not. Yeah.
So in the last couple of years also, both the name server and syslog have been made to work in both the iOS and Junos routers to go over the IPv6 transport. So as there was a comment earlier before, right, the routing works, but some of the network services are still things that are work in progress, and that is true. But for both Junos and iOS, actually name server and syslog can be accessible via IPv6. Mm-hmm. And these here are the commands that would enable that. So for iOS, you would say IP name server and put in the IPv6 address. Well, the other one is the IPv4. Same for iOS XR, you would actually use domain name server as the key command, and then that's the Junos configuration.
Yes.
Just to sort of jump back to the interface configuration. Sure. Some people may be configuring interfaces onto a public exchange or to a peering point. And I know that certain exchange points have certain criteria or certain requirements for interface configurations of IPv6. I don't know if anybody here is from an exchange point operator. Okay. Can you maybe touch upon some of those special requirements like neighbor discovery and so forth?
Yeah, this slide is basically what I was mentioning earlier, that when you're actually enabling IPv6 on a platform, be aware that IPv access to the control plane is now possible via IPv6. Right, so make sure that you do your control plane filtering also on IPv6 as well as IPv4. And you know, it's something that isn't in the slide set, but what Mike just mentioned actually regarding turning off neighbor discovery and also, you know, router advertisements. Typically on your peers, you know, you don't need router advertisements and router solicitations. So it's usually on by default on the interfaces. So from a router to router peer connection, you want to disable that. Now, how many do not know what I mean by this? Okay, I figured since most of you played, I mean, you do know this. So. Okay, so yeah, so also, I mean, you guys seem to be pretty familiar with IPv6, which is great. Note that configuring an IPv6 address, you will have both a global and a unique local IPv6 address, and also a link local IPv6 address, which is the FE80::: interface ID. So the link local address is basically constructed by concatenating the FE80 with the interface ID as soon as the IPv6 is enabled. So the next slide actually shows that. So from a Cisco router, if you do IPv6 unicast routing, so you're enabling IPv6, when you do a show IPv6 interface, it will show you that you have a link local address that's automatically generated, and automatically you're already part of a couple of group addresses, like the all routers address and some others. You can also look at an interface status, and basically this is what the output would look like. And this is just shows what it would be on the XR router. How many of you are using XR routers here? Is anybody? Just a few of you, okay.
And this is a similar output in Junos. Now, we've brought up our interfaces, probably pinged across interfaces and said, yep, that works. Now it's time to bring up a routing protocol.
Or not. Or you want to do static routing. So
That's true.
Yeah. So hopefully you're not doing this. Hopefully you're doing either OSPF, ISIS, or BGP. But if you wanted to play and you needed to do a static route, maybe to a customer actually, then the configuration command is very much like in v4. It's IPv6 route, put the IPv6 prefix length, IPv6 address, interface type, a number, and then an administrative distance. So this particular example shows that you're routing packets for network 2001 DB8/64, so 64 subnet, to a networking device at 2001 DB8 CC001 with an administrative distance of 110. And for those of you that may not know this, right, the 2001 DB8 is a documented interface. So Philip is very, very, very good at always making sure to use that rather than a subnet that might be live somewhere. So anytime you actually do any documentation or presentation, please also use the 2001 DB8/32.
Quick question regarding statics. For v4, I use a null hold down route for my allocation, and that just is the way I'm used to configuring BGP to announce that large hold down. Do you need to do the same with v6? I'm assuming you do. Question?
In Junos land, it works. In Cisco land?
I believe the same is true, but I'm going to validate.
Okay.
So
Anybody who's
Yeah,
set up
does
v6, they're using null hold down routes? Yeah. So
I'm pretty sure, yeah.
translates.
Also, something you should note is on the SRX platform, Juniper's new flow-based routing, you can type in all of the IPv6 commands and it accepts it happily, except there's no backend code to support IPv6. So you'll see it in your Junos configuration, but SRX does not support it.
Yeah, the feature's not quite there yet.
Yeah, but the configuration options are.
All the examples you see here, when I did the Junos examples, it was on an M-series router. And back then, I think it might have been Junos 7.6 or something like that.
Okay, for static routing, this is the command for the iOS XR router. So basically you have router static, address family, IPv6 unicast, and then you set your, to your next hop. So this example again shows it routes packets for the network 2001 DB8/64 to a networking device at 2001 DB8 0CC001 with an administrative distance of 110.
And here's the Junos example. The first thing that's interesting is where it goes in the configuration hierarchy. Routing options, RIB, INET 6, because it goes in the INET 6 fib. And beyond that, you'll see it looks pretty much like an IPv4 route, except for the fact that it has IPv6 prefixes in it. And here's an actual example. In fact, it's the exact same example we just saw in iOS land.
Yeah, so of course you can also set a default route. So in this particular example, right, you have the IPv6 unicast routing, IPv6 addresses underneath both Ethernet 0, Ethernet 1 interfaces, and then the IPv6 route ::/0. The ::/0 is all zeros, which is the default route, and then you would enter the address of the router to Ethernet 0 interface, because that's the exit interface, which would give the default route to router 2. So you can already see that actually doing static routing is almost a configuration nightmare, right? Because you actually have to know the next hop IPv6 address. So any of you that have configured it know that you would probably want to avoid it as much as possible. And here's a similar command for XR. I mean, nothing really unusual or interesting here.
And in the world of Junos, it's pretty much could have, in the world of Junos, you pretty much would have guessed what this configuration looked like from looking at the previous slide.
Yeah, so for the most part, I mean, dynamic routing in v6 is really not that different from v4. I mean, sometimes there are slight configuration nuances, because I know from Cisco, like the parser police, I guess, was asleep or just non-existent. So, but basically how it works, it is very, very similar. So IPv6 also has two types of routing protocol, internal or external. IPv6 still uses the longest prefix match routing algorithm. So for IGPs, you have either RIP, which I don't think a lot of ISPs would even use. You have Cisco EIGRP. For obvious reasons, Juniper doesn't support it. You have OSPF v3 and integrated ISIS. For EGP, exterior gateway protocols, you have the multi-protocol BGP4. So basically that's multi-protocol for both IPv4 and IPv6.
Basically what we're saying here is that you have the same tools in v6 that you had in v4. Sometimes you had to hit the tools with a hammer a little bit to make them work in v6, but same thing.
I just want to point out you can also use IBGP for the IGP to carry v6 routes as well.
Right. Yeah, so BGP can either be an internal or an external gateway protocol. So thanks for pointing that out. I'll send a note to Philip. So if you're configuring the routing protocols for iOS, the dynamic routing protocols all require a router ID. The router ID is a 32-bit integer, and sometimes people get a little confused because sometimes it kind of looks like an IPv4 address. That's not what it is. iOS auto-generates these from the loopback interface address if it is configured, else the highest IPv4 address of the router becomes the router ID. Most ISPs will deploy IPv6 in dual stack. I don't think I've seen any yet that only have IPv6. So the router ID will actually be automatically created, from your IPv4 configuration. Early adopters choosing to deploy IPv6 in the total absence of any IPv4 addressing needed to be aware that the router ID needs to be manually configured. And so, for example, under OSPF, we have IPv6 router OSPF Autonomous System 100. The router ID is 10.1.1.4. So again, if you're in a dual stack environment, then from your IPv4 configuration, the router ID will automatically already be created. But if you're doing IPv6 only, then you actually need to specifically specify what the router ID is.
Now, I have a question here. In my experience as an operator, I know that the router ID can be automatically generated, but it can also be specified in the config too. And I used to like to put it in the config for fear of what would happen if one day it changed. Somebody put a new highest address on. I didn't really want to test the router's behavior to see if it would change the router ID or not.
It's actually a good point.
I'll just put something that I know would stay still.
That's a good point. So some people might actually want to do that so that they can be assured that if there's an interface change or, that the router ID won't actually change.
Okay. XR.
So for IPv4 routing protocols, the XR auto-generates the router ID as per the iOS rules, actually. But BGP requires the router ID to be manually configured. So the command would be router BGP 2.4 and then set the router ID. OSPF v3 requires the router ID to also be manually configured. So router OSPF v3 and then configure the actual router ID. So that actually speaks to exactly what you were saying. So with the XR, it doesn't get automatically generated, but rather an operator has to say what it is.
Juno, same thing. You can either let the router generate the router ID or specify it explicitly. I'd recommend specifying it explicitly.
So RIP next generation, basically for any ISPs, as Philip says, and I totally agree, don't go here. ISPs really don't use RIP in any form unless there's absolutely no alternative. Possibly maybe to a customer site. How many of you do use RIP at all to a customer site? Didn't think so. So we'll just skip that. So EIGRP for IPv6. Cisco, of course, why would they not add IPv6, right, to EIGRP? Just has a couple of new TLVs. Routing ID is still, the router ID is still a 32-bit. Protocol is still 88, so that didn't change. Similar CLI to the IPv4. I guess it started in 12.4, not in iOS XR yet. So. So some differences, and I will do a caveat. I've actually never configured EIGRP for IPv6. I've just done it for OSPF, ISIS, and BGP. But hellos are sourced from the link local addresses and destined to FF02::A, which is actually the multicast group for all EIGRP routers. So this means that the neighbors don't have to share the same global prefix, okay? Except with the exception of explicitly specified neighbors where the traffic is actually unicast. Automatic summarization is disabled by default for IPv6, so that's a difference from IPv4, where it's actually automatic summarization is enabled. So if you want auto summarization, you will have to enable it for IPv6. And there's no split horizon in the case of EIGRP for IPv6 because IPv6 supports multiple prefixes per interface. So again, that's different than IPv4. So here's actually a configuration. Looks very much like IPv4, where you have just do router EIGRP, so enable the EIGRP routing process. And under the interface, enable your IPv6 address, say IPv6 enable, and then put down that that interface actually participates in the EIGRP process. So exactly the same as before. If you do a show IPv6 EIGRP neighbor, basically the neighbor is identified by the link local address, right? So the FE80::, interface ID. And you'll see that to the right on the bottom also, or in the middle, you can also see the router ID, which is a 32-bit integer.
Okay. OSPF needed to be changed a little bit to accommodate IPv6. The problem is there are IPv4 packets embedded in the OSPv2 protocol, and just needed to fix those packet length issues. So there's a whole new protocol, OSPF v3, which looks surprisingly like OSPF v2. Surprisingly like OSPF v2 in these ways. It's OSPF for v6. It's based on v2 with a few enhancements. Obviously, it distributes v6 prefixes. It runs directly over v6, the same way v2 runs directly over v4. And it ships in the night with v2. If you have both address families activated on an interface, you're likely to have both v2 and v3 running, and they won't interact with each other. The protocols are very similar. They have the same basic packet types, hello, database distribution, link state advertisements, all that good stuff. The same mechanisms for neighbor discovery and adjacency information. Same interface types, same LSA flooding and aging, nearly identical LSAs. A few significant differences. OSPF v3 runs on a link instead of on a per IP subnetwork. Do we need to delve into this at all, or just believe that turn it on, it works? If you didn't understand that point, you would be able to use the protocol just as well as if you did. Well, let's see. There's quite a few here, so we probably should run through these a little bit. Do you want to?
Sure.
We're on 48.
Yeah, so basically OSPF3 runs on a link instead of a per IP subnet. In IPv6, multiple IP subnets can be assigned to a link, and two nodes in different subnet can actually communicate at a link layer. And therefore OSPF is running per link instead of per IP subnet. Okay, an interface connected to a link and multiple interfaces can be connected to a link. I don't know about that one. But anyway, the more interesting things to me actually are that you can have support of multiple instances per link. So you can actually have multiple OSPF instances running on a link. The instance ID should match before a packet being accepted, and it's useful for traffic separation to have multiple areas per link. There's also an address semantic change in the link state advertisements. So the router and network link state advertisement carry only topology information. The router link state advertisement can be split across multiple link state advertisements. So link state ID in the link state advertisement header is a fragment ID. Right? If you remember that for IPv6, you've got a whole bunch of extension headers. And so one of them is a fragmentation header. The intra-area prefixes are carried in a new link state advertisement payload called intra-area prefix LSAs, and the prefixes are carried in payload of inter-area and external LSA. There's also generalization of flooding scope. So in OSPF v3, there are 3 flooding scopes: the link local scope, area scope, and autonomous system scope, and they are coded into the LS type explicitly. In OSPF v2, initially only area and autonomous system-wide flooding were defined. There's also a difference in terms of how unknown LSAs are handled. So the handling of LSAs is coded via the U-bit in LS type. When the U-bit is set, the LSA is flooded with the corresponding flooding scope. When the U-bit is clear, the LSA is flooded with link local scope. And in v2, and any unknown link state advertisements were discarded. So there is actually different differentiation between behavior in v2 and v3.
The other, oh, sorry.
No, go ahead.
That's actually the security one, so why don't you go after that?
Yeah, so this is near and dear to my heart because I always thought this was kind of really interesting. So authentication is removed from OSPF, and it was removed because OSPF relies on the IPv6 authentication header since OSPF runs over IPv6, right? And the authentication header is part of the IPsec protocol. Now, what I've really found fascinating is that when OSPF v3 was first created, the assumption was that all IPv6 traffic would be protected using IPsec. And since you don't need encryption, well, you just need integrity protection. Well, of course, you would implement AH, which is the authentication header. But as the IETF began to be more explicit about how you actually use IPsec, in the actual standard that was defined, ESP null which is using ESP that does encryption, but using null encryption, no encryption, is actually what must be implemented, and AH is a may. So to me, it's kind of funny because most vendors, who've been shipping OSPF v3, which is, I don't know, for at least 6, 7, maybe even 8 years, all use the AH, the authentication header. So to me, it's been kind of interesting, whether or not people are going to start using ESP null and how do you actually configure it, because it's kind of a nightmare.
And this is kind of almost an inconsequential change. The OSPF packet format's been changed. Math fields removed from the hello packet. IPv6 addresses are present in the payload.
Okay, there's also 2 new link state. What's the acronym stand for?
Link state advertisement.
Yeah, okay, so it is. Yeah, so 2 new link state advertisements have been introduced. So the link LSA has a link local flooding scope and has 3 purposes. One is it provides the router link local address. Another one, it lists all IPv6 prefixes attached to the link. And also, thirdly, it asserts the collection of option bits for the router link state advertisement. The second one, there's an intra-area prefix link state advertisement to advertise the router's IPv6 address within the area.
Finally, what you've been waiting for, how do we turn it on?
Yeah, it's very similar to OSPF v2 in the Cisco routers. Basically, you just prefix any existing command with IPv6. And with the interfaces that are directly configured, you just replace the network command and basically the native IPv6 router mode. It's not a submode of router OSPF. So the next should be, yeah, so here is actually entering the router mode. You say IPv6 router OSPF process ID, and then configure the area under the interface, so IPv6 OSPF process ID, what area it belongs to. And then in exec mode, you can do either show IPv6 OSPF process ID, that'll show you the information, or do clear IPv6 OSPF process ID. So there's some specific OSPF v3 attributes. So configuring an area range, and you do that with the area, enter the area ID, the range, and then the prefix and prefix length. Showing the new link state advertisements, you do a show IPv6 OSPF process ID and either database link or database prefix. And then you configure authentication by just saying authentication IPsec SPI 256 MD5 password. So this is basically what a configuration would look like. I don't really have any comments on this. It looks very much like OSPF v2. Do a show IPv6 route. You see that, this is what the OSPF would look like. You could also do OSPF v3 and do IPv6 tunnels over IPv4. So how you would set that up is you would create an interface tunnel on each router. No IP address, so no IPv4. IPv6 address, just enable that. Create an IPv6 link local address. Specify the router OSPF, area 0. And then create a tunnel source and destination with your IPv4 addresses and the tunnel mode IPv6 and IP. And of course also enable IPv6 router OSPF1. And then do a similar command on router 2 to actually, have it be the other endpoint, tunnel endpoint. And these commands here are how you actually configure OSPF on the XR router. You had a comment?
Quick operational question for anyone here. I use IPv4 Anycast for my core DNS servers, so I have multiple of them in different regions of the U.S. Right now I implement that with Quagga using OSPF to advertise a /32 to my upstream routers using an OSPF not so stubby area. Has anybody done that sort of thing with V6 and OS? Exactly the same? Awesome, thank you.
Yeah.
Where like the last bit is the port number or something. Sure, cool. That's a really good idea.
Yeah, thanks for that. I mean, my observation also has been that from the routing pieces, I mean, there's really very little that's different from IPv4 or IPv6. There's some nuances, right? And as we just went through also with OSPF 2 and 3, I mean, there's some enhancements, if you will, that were done with OSPF v3. But if you look at actually how you configure it, there's really not that much difference. Right. I'm not going to go over the XR.
Okay.
Yeah, so for the XR, these are just configuration examples. I'm not going to go through them in detail.
Okay. And now it's time to do it in Junos land. That stanza protocols should look vaguely familiar to you. It's exactly the same configuration that we would use in OSPF v2, except we say OSPF 3 and we're done. Show OSPF 3 is the equivalent of show OSPF, and you have all the same options: database, interface, I/O statistics. Clear OSPF 3, exactly the same as clear OSPF. And let's say, no differences from iOS, I guess. The issue that Merike talked about with the authentication header, we also have. Actually, do I see the carp chair hiding in the back here? How is the carp chair disposed towards OSPF v3 and authentication?
Okay, thank you, Ron. For those of you who don't know me, I'm Joel Halpern, and we've recently chartered over at the IETF a working group specifically to work on refining the pragmatics of the security in routing protocols. It's called CARP, Keying and Authentication for Routing Protocols. We know that most of you have implementations which support this. They've just been talking about the authentication support, and that most people either don't bother turning it on or never change the keys. And security that you turn on and never change the keys, you might as well not have turned it on. So we're trying to address a number of known issues. And one of them is, should we replace the AH with a specification to use ESP null or something else? We're going to go through the threats to all of the routing protocols that are in use, and OSPF v3 is one of them. But in general, we need participation from our operators about what you guys are seeing as the real problems with using security. Because if we don't fix it so you can use it, we've wasted our time.
Thank you for that. And, you know, I'll just add to that, too. There's also an operational security working group in the IETF. And I know that there is a draft in there that actually talks about all the all the kind of security issues within routing protocols. And I can't remember offhand what it's called, but if you actually go to the IETF list and look at the operational security working group, one of the drafts right now is one that talks about issues with routing protocols and even some of the crypto.
I'll post links to the two charters, CARP and OPSEC, on the NANOG list tonight. Okay, here's the identical configuration example for our two routers, OSPF neighboring with each other, and it should look vaguely familiar. And it's probably not a whole lot to speak to here either. It should look vaguely familiar. Here's a look at what v6 routes look like on the routing table. And same show commands, show route. And the exact same tunneling situation that we had a few slides back, we can recreate here. But there is one thing that I should point out. Depending on the platform you're using, you may or may not need an application services pick to support tunnels. So if you're, say on a M40E, you're going to need the AS pick. Other platforms might not need it. And I won't step through the configuration, but if you're doing something like this, you can use this as a template. And on to ISIS.
Just one note regarding the platform.
Mm-hmm.
On some platforms, these functions may be supported, but it may not be optimal for you to run too many of them because it's done in software. So that's where the multi-services cards come into play. If you're going to use encryption and tunneling.
There's always a trade-off between a processing intense service and scalability. If you want the processing intensive service to scale, you need that extra piece of iron to make it work. Okay.
Okay, so ISIS, mostly, right, people, when they run their internal gateway protocol within ISPs, I mean, the choice is usually OSPF or ISIS, and typically it's more, what are you more familiar with? With ISIS, the ISO 10589 standard specifies OSI ISIS routing protocol for CLNS traffic. There's TLV options to enhance the protocol. I call them type length value. I don't know if tag's the right word. A link state protocol with two level of hierarchical architecture. RFC 1195 added IP support. So ISIS runs on top of the data link layer. It also requires CLNMP to be configured. RFC 5308 added IPv6 address family support to ISIS, and RFC 5120 defines multi-topology concept for ISIS. One nice point about ISIS is that you only have to run one protocol instance for actually to have IPv4 and IPv6 running. So you don't have to have two instances of the routing protocol like you do with OSPF. So ISIS for IPv6, you have two tag length values added to introduce IPv6 routing. You have the IPv6 reachability TLV, external bit, equivalent to the IP internal and external reachability TLVs. And you also have the IPv6 interface address type length value. For hello, PDUs must contain the link local address. For LSP, must only contain the non-link local address. The IPv6 NLP ID is advertised by IPv6 enabled routers. Here's actually a configuration example for Cisco iOS. So for router 1, you have interface Ethernet 1, have an IPv4 address and IPv6 address, specify both for IP, which is IPv4 by default, and then IPv6 that it wants to participate in router ISIS. Do the same for Ethernet 2, and then for router for the actual routing, configure router ISIS, address family IPv6. Here he wants to redistribute static. And then you configure an exit address family and redistribute static for IPv4. You can also configure ISIS for IPv6 by doing an IPv6 tunnel over IPv4. Same basic configuration applies as for OSPF, where you just define an IPv6 global address, a link local address, specify that you want to run router ISIS, and then have a tunnel source and destination be the IPv4 addresses. And this here is just configuration commands if you're going to do ISIS on the XR router.
Okay. Here's the Juniper equivalent configuration, you'll notice that, well, we have an interface that is configured with family INET, so it can have an v4 address, family ISO, and family INET 6. Then we turn on protocols, again, redistribute statics, and put all those interfaces into ISIS. And we have some policy options that say that we will accept anything from static. Again, the same tunneling that we could do with OSPF, we can do with ISIS. And in case anybody's doing that sort of thing, they can use this as a reference. Anybody interested in multi-topology ISIS extensions? Anybody using ISIS? One. Anybody using multi-topology stuff? Okay, skip over multi-topology.
Yeah, I think the only point that we should make on the multi-topology ISIS is that there might be an assumption initially that you have the same topology for IPv6 as you do in IPv4, but if you don't, if you actually have a different topology for your IPv6 and ISIS, that's why this multi-topology extension was actually created. So.
Okay, we're coming down home stretch with BGP. I think this is the last routing protocol we'll talk about. RFC 4760 defines multi-protocol extensions for BGP4. So BGP4 can move around any kind of address family in the world. RFC 2545 uses BGP multi-protocol extensions for IPv6. So those are the two relevant RFCs. We have new optional and non-transitive BGP attributes. Now, what does that mean, optional and non-transitive? Optional means that every BGP implementation doesn't need to understand it. Non-transitive means just because you got it, you will not pass it on. Transitive would mean that you would pass it on. The two new attributes are multi-protocol reach NLRI and multi-protocol unreachable NLRI. These attributes contain one or more triples of AFI. What family is this address? Is it V4, V6, MPLS, V4, VPN, V6, VPN, whatever. Next hop must be the same address family and the NLRI. RFC 2545 gives you some V6 specific extensions, scoped addresses. Next hop contains a global IPv6 address or potentially a link local address. Next hop and NLRI are expressed as IPv6 address and prefix, and AFI equals 2. Let's see, BGP considerations. Do you want to? Oh, okay. Rules for constructing the next hop attribute. When two peers share a common subnet, the next hop information is formed by a global address and a link local address. Redirects in IPv6 are restricted to the usage of link local addresses. And having written the slide myself, I can't remember what the heck I was saying. Sue, you're in the room someplace, no? Can you help us out with this? Okay, in V6 land, are there any particular rules about choosing the next hop? It's just the V6 loopback address of the egress gateway.
Yeah, I think one of the problems is that for using redirects, right, I mean, you're restricted to using the link local address, so it's not the global unique address.
Okay. You know, I'm a very pragmatic ITF person, so let me be a little bit more pragmatic here. Reason we went to both is because people ended up with some errors if they had one or the other. Now, an intelligent life form, which I'm sure includes all of you, may be able to make either one work, and that's probably the best way to give why we have both, that if you don't have both, there are cases where you can hang yourself. Most intelligent configurations don't hang themselves. Is that, otherwise I can get down into the nerd weenie moments, but I didn't think.
Okay, thank you.
I mean, if you want me to go to the nerd weenie moments, I will, but otherwise I'll just be pragmatic.
Sorry to put you on the
Now,
spot.
and here's the difference with IPv4, right? With IPv4, you look at the next hop, you get an IP address, right? With IPv6, the next hop is either your globally unique address or also your link local address. And I think that can be a point of confusion to some people.
Yes, if I've got everything there, okay, yes. I think I'll let it go. I mean, there's one exception, but we'll take that offline. And if there are questions, I'm glad to answer it. But I'm also cognizant of we've gone into the weeds on this 4 times because people have had problems. And again, most of the problems occur with non-standard topologies in an exchange point, or 3 hops into the exchange, having exchanges that go across perhaps layer 2 transparent stuff. So if we want to go on with that, I can, but otherwise, yes.
It's okay. I think the point is really, though, that, you know, with IPv6, you do have to be aware that, you know, every interface does have a link local address. And then, you know, it's up to you to actually configure also a globally unique identifier. And when you're looking at BGP, right, as the slide here says, when you have 2 peers on the same subnet, your next hop information is formed by using either, right? I mean, it's either the globally unique identifier, but also the link local. So when you're actually starting to, you know, configure BGP and you're looking at your BGP routing tables, I mean, you know, don't be too confused with the fact that you'll probably see both.
Right. To be safe, you need both. The Japanese have successfully proved you can do link local if you're careful. But in all of this for a tutorial, please use both. You probably won't shoot yourself. If you want to go to singly link local, come talk to people who've done it so you don't shoot yourself in the foot.
That's fine.
Okay. And this slide is fairly self-explanatory. There's one RIB per protocol. IPv6 has its own BGP table. You'll see that in the show commands.
Okay, and this again addresses what we were just saying before, that the next hop contains a global IPv6 address or potentially a link local address. And the link local addresses as a next hop is only set if the BGP peer shares the subnet with both routers.
Okay. Interaction with TCP is same as with V4. BGP runs over TCP. This connection could be set up over V4 or V6. BGP doesn't know one way or another. Router IDs, when no router ID is configured, an explicit BGP router ID needs to be configured. It's generally good practice to configure it anyway. The BGP identifier is a 32-bit integer currently generated from the router ID. This is needed as a BGP identifier. It's used in the open message and in tiebreakers for BGP best path. Okay. Here we go again. There are 2 options for configuring BGP peering. One is to use link local addressing. Do this only if you like staying awake late at night and debugging. Others to use global unicast addressing, which is what you would have done in v4. Do this if you like going home to see your family.
Yeah, and I think, I mean, since, I'm doing this as a replacement to Philip, I can only guess that the reason that, these slides are in here and talking about the same thing in multiple forms is because it will really bite you at some point. And so basically it is not recommended to use the link local addressing, right? And I mean, the recommendation to actually set your next hop is to use global unicast addressing. I think it'll just make life a lot simpler.
The number of ways you can mess it up far exceed most of your night's sleep, so don't do it.
Okay, so in iOS routers, basically in iOS, by default assumes that all BGP neighbors will also be IPv4 unicast neighbors. So you have to remove this assumption. And how you do this, you enter the router BGP AS number, no BGP default IPv4-unicast. And if you do not do this, this will result in all neighbors being defined as IPv4 unicast neighbors, which is not necessarily a good thing, because non-IPv4 neighbors will have no specific unicast IPv4 configuration, and it just ends up in cluttered configurations. So to actually create BGP peering in iOS, router A, under router BGP 1, router BGP tunnel system number, you say no BGP default IPv4 unicast, and then what the neighbor is, and here, as a good citizen, of course, he's using the global IPv6 address, and then remote autonomous system 2. And then address family IPv6, neighbor, the neighbor address, activate, and then which network you want to advertise, which is the 2001 DB82/48. So you do not want to do link local peering. Again, we're beating this horse to death some more. Okay, use global addressing. So I got to send Philip a note. How many different ways can you say the same thing? Wow.
We can show the picture of Rocco again.
Yeah. So, and this is just a configuration snippet for iOS XR. And I haven't configured an XR, but I guess, the real important point here is that you need inbound and outbound route policy because the iOS XR does not announce or accept prefixes without any policy, which is really, really nice. Go ahead.
Here's the Junos configuration. Again, we start out by configuring an interface that is v6 capable. We configure a static route that we're going to distribute. We configure a router ID. And we turn on protocols. BGP. It doesn't know if it's BGP trucking around v4 or v6. The local AS is 1. Then we have a group of neighbors that we call AS2. We have a export policy for it. We have an export policy for it, export static. You'll see that in a little bit. It will be AS number 2, and the neighbor has an address 2001 DB8 blah, blah, blah. Up above, we talked about what the export policy was. So here we have to actually say what it is. Policy options, policy statement, export static, term 1 from protocol static, then accept. Everything else rejected. This looks an awful lot like just plain old BGP configuration.
Okay, this particular example, next couple of slides, are basically comparing the prefix list and filters for IPv4 and IPv6. And what you will notice that the IPv4 prefix filters and the IPv6 prefix filters are exactly the same, with the exception that you have the IPv6 keyword rather than IP. And of course, you're either permitting or denying IPv6 addresses. And there's also a configuration sample for IPv4 and IPv6 on iOS XR.
What slide are you on?
106, 105. Yeah, and you'll have these slides. I mean, they'll be up on the mailing list. And with the iOS XR, you'll just note that the per address family configuration per neighbor and the prefix sets are similar to iOS prefix lists, but there's no distinction between IPv4 and IPv6.
And here we've done the exact same thing with Junos. We have a dual stack enabled interface, FE300. We have a RIB, INET6. We also have INET0, which is there by default. We've given it a router ID. We've turned on BGP, and we have two groups of neighbors. One group of neighbors in AS20, another in AS30, and we have some policy for each.
Yeah, this next slide actually just shows the fact that you can also do a route map and set local preference to be something that you yourself define, right? And it's exactly the same as you would do for IPv4. So under the address family IPv6, right, you set a route map from AS2 in, and then you create the route map from AS2 permit 10, and then set local preference to 120. Here's a similar configuration for iOS XR. But really manipulating any kind of attributes in BGP, the commands are almost identical in IPv6 as they are for IPv4 and iOS XR.
And you guys are probably getting tired of hearing this say, this is how you do it, and this is how you do it in Junos. But here again is the identical configuration in Junos. And in this case, the attributes we're manipulating are local preference, and you see them in the policy.
Okay, you can also carry IPv4 inside IPv6 peering. And so for the iOS, for the example, what you do under address family IPv4, you basically define a route map IPv4 in, and the route map would set the IP next hop to be your IPv4 address. So there's another example for the XR router.
And it's kind of the same thing in Junos. BGP is, rides over IP whatever. That rides over TCP. And the BGP payload can actually carry any family of address. And it doesn't care if it's, V6 address over V4 or V4 address over V6 or some other kind of crazy address over one or the other. BGP status commands for iOS. I'll let you peruse those at your leisure.
Yeah, I mean, again, you'll see that really the only difference from IPv4 to IPv6 is that you use the keyword IPv6. Like in IPv4, you don't have to use anything. You can just say show BGP unicast parameter. But for V6, you have to actually say show BGP IPv6, blah, blah, blah.
In Junos, there's a display command. One thing that's interesting is it shows you each RIB individually, INET60, INET62, and INET0. INET0, strangely enough, is for IPv4. And more Junos summary commands. Conclusion. Well, I guess the conclusion is, if you are turning on V6 in your network, the configurations are actually frighteningly similar to the V4 configurations. You know, a little tweak here, a little tweak there. Use these as guidelines and, you know, maybe templates to do your configuration. You know, operators have gone through all the pain with with BGP, with IPv4 and BGP, so they know what kinds of things to worry about, and for the most part, they're the same in V6. So, jump in, have fun.
Yeah, and so the only comments that I want to make as a conclusion is that if you're using OSPF, ISIS, BGP, I would strongly recommend that you actually do use authentication of the peers for either routing protocols. And mostly that is, it's just so you don't shoot yourself in the foot, you know, in case somebody makes configuration errors. For BGP, it's more important because it runs over TCP. You don't want somebody spuriously sending you TCP resets or anything like that. With ISIS, remember that it's one routing instance for V4 or V6, whereas with OSPF, you have to run, you know, one for V4, another one for V6. But as Ron also said, I mean, most of the configuration commands are actually frighteningly, you know, identical to V4, which is a really nice thing.
I got a question about, I'm just curious, you know, with the ability to carry, in BGP, carry IPv4 routes in V6, I'm just wondering, people typically doing that, or are you just typically bringing up both V4 and V6 neighbors?
And in my experience, people have used BGP to carry a single session to carry lots of different kinds of routes. VPN routes, IPv4, IPv6. The only reason I could think of for wanting to run many instances is if you have a lot of one kind of route and not a lot of the other, and you're worried about which you're going to get there first, or who's going to converge first, or who's going to be a bottleneck behind the other.
And kind of on that note, with all the routing protocols, if you're running a dual stack network, you've got machines or servers or services that are dual stack as well. You really want to make sure to keep you sane that your V4 and your V6 configurations are as analogously simple, as analogously similar as possible, because you will run into very nasty diagnostics problems otherwise.
Ron, can you clarify that point? Were you saying that people are carrying IPv4, V6, everything within a single neighbor?
I know that there are some that do that. There are some that split it on multiple neighbors so that, you know, they have concerns that they have a lot of this kind of route and just a few of that kind, and they don't want one getting caught behind the other.
What we're finding is that, like on the Seattle Internet Exchange, we have everybody carries V4 and or V6. Because a lot of the networks that are coming in, some are only going to have a completely isolated V6 network. You can't carry that over V4 here.
Yes, in the case where it's completely isolated network, of course they're different. I'd like to reinforce what, I'm sorry, the last fellow was at the mic, I forget your name. What Jake said. You really want your V4 and V6 configurations to be as analogous as possible. If you were in the habit of using, you know, explicitly configured router IDs in V4, do it in V6 too. You want as little to change as possible because change is generally a bad thing. Any other questions? Is it time to hit the bar? Okay.
Yeah, thanks for attending.
Thank you.